the distinction between a simple chat JSON endpoint and a calculator job is the naming is a bit different on the worker side. We have RPC job here. Not sure about it naming, and we have a calculator. So either RPC or calculator. In both cases, now we are looking at the worker module, this function, and this function is invoked in the front end process, and they enqueue the message, and the actor function lives in the worker process. And we get to invoke RPC module. And let's see what the, so this is a local calculator in the sense that we are in the worker container. It also should be fairly easy to trigger these actors manually if needed for debugging. There's like a CLI module here somewhere. That should help you run requests from the command line if needed. Worker CLI. And this is all it does. It exposes the local calculator and the local RPC functions. The local calculator and the local RPC. There's a bit of trickery because these are annotated as remote actor. So we are getting the original function through the fn property. And this is just exposing them to the CLI framework. So you can invoke them on the command line, using the exact same arguments as the front end server does. So what happens in the local calculator? It constructs the message. The message is mainly to be interpreted by prolog code. Last request, symlink, symbolic link. We have those in the TMP directory. Don't rely on them too much. It's just for debugging. And so here we are already on in the worker process, and we call invoke rpc.call prolog calculator. A bit of trickery here. Request format is probably needed on the prolog side, but this is one of the not so figured out areas yet. We probably do need at sometimes to specify what kind of requests the client is making, what to do with the files. But at the same time, there is this idea that we should be able to just read whatever documents we are given and interpret them according to some templates or parsing rules or whatever, and just try to produce a complete model of an organization's accounting. But as things are, we are gonna see the request format being used. In the prolog side, process request with request format. And this is all we really know. Either it's a quote unquote legacy XML request or a new style RDF request. The legacy XML request format comes with some limitations, but part of that is really because of the Excel plugin frontend code not being able to do things asynchronously, or it would take a lot of work to rewrite some of that or to improve it. So there are some overlapping concerns. Anyway, for XML request, we have a car endpoint, a loan endpoint, and livestock endpoint. We should also standalone. Okay, we don't have the standalone investment endpoint anymore. And we have completely replaced the old ledger XML endpoint with the RDF one. So these are the more simple endpoints to explore. Car was just a simple experiment. It really just invokes another service. Parse the incoming XML. Validate it for some reason. And invoke the other service. Pretty much. Alone is a more complex one, a little more complex one. But again, it's the same scheme. Parse the XML, validate it, even do some calculations in loan.pl, some 600 lines, and produce an XML response. And what we do in these cases is we okay, yes, we write the response to some response XML file here because we are kind of working within the calculator infrastructure of files and report entries. Okay, and going back to process requests. Process request RDF. Or what was it called? Process RDF request. So two different endpoints making full use of the newer RDF format. Not XML. That's just some legacy code. This is the what is called investment calculator on the front end is historically called ledger here. So a lot more complexity. We will get to all of this. Let's go back to the worker. Python code. So call prolog is the more simple case that just passes some message into prolog and on the other hand, the calculator does some setup of result directories So let's see. Okay, this is where we were. So this is a bit of a hack. If the file name ends in XML, we assume that it is an XML request. At some point, we are gonna want to be able to run the investment calculator with some XML files, maybe, but for now, it gets the job done. We create the result directory. We store the name in the message that is sent to the prolog process. And this is a bit of a trickery. We are running under the worker process under remulate actor, and the message ID is our job ID, and the job ID is also the name of the directory where, well, we don't store any files there, but we put the symbolic links to the results directory here. And what is gonna happen is a worker starts working on, processing a job, and it's killed by Docker daemon or something happens, and the message is not flagged as processed, and then, or maybe we restart the container or the whole stack, it comes back up and it picks up the same message. So another worker creates a new result tmp directory and adds the symbolic link to the job directory and attempts the processing again until it successfully finishes, or an actual error is returned or something like that. So yeah, we want to have the job ID. Make sure all the directories exist. Last result symlink. Creating symbolic links is tricky. You have to find some safe directory where you can, because you have to take into account the possibility that there is another worker process concurrently creating the same or working in the same directory or something like that, or that a symbolic link already with the same name already exists. Like one worker is creating a last result symbolic link and another worker is doing the same at the same time. So yeah. Git info. Every job gets a git info file. This is one way that we try to make results replicable. If you have not seen it, it's the full output of git log plus git diff commands or something along those lines. So at all times we know, not exactly, but we can get some idea what version of robust server produced a result report set. Okay, and finally we descend to the simpler call prolog. Call prolog doesn't care about a request or result directories. I mean, almost. It cares about the worker configuration. So as it is currently set up, there are some default options. Worker configuration as it is, it's mostly, well, it's a bunch of different things really. Some control the prolog side, some control the Python side. We can see some defaults. We can see some defaults here. This is for prolog code. This is for the prolog wrapper script. Prolog process, prolog code, I mean like robust code, robust code, robust code. And here we see, we don't specify the defaults for all these flags. Prolog actually, our prolog code does specify defaults for probably all of them. Like default. This is how we specify the default value. And this is clearly for the Python side, how exactly to invoke the SWI prolog process. So we have some defaults, and we override that with the worker config JSON. So the worker config JSON is loaded each time call prolog is called, so it's loaded for each request or each attempt at processing a job. So we don't have to like restart the whole Docker stack after you change the worker config. And then we override that with the options passed as arguments, and these come from the request JSON that the client can send. Options optionally coming from the worker options in request JSON. So that was the configuration dictionary. And again, an attempt at some traceability, accountability. And then we construct the command line for SWI prolog. This part could probably use some cleanup. There. And we also invoke the prolog process with this environment, which is the current environment inside the worker Docker container as brought up by the generated stack YAML file and the maybe the environment used when invoking the Docker compose command. And anyway, the point is we have some environment inside the worker container, and then we override some values. Well, we actually use all the items in the options dictionary. So the options dictionary can override currently any environment variable. We're not actually invoking the prolog process, but another wrapper prolog script, the dev runner, which has like a bit of an ambition to also be a standalone script useful when developing even other prolog programs. It does a couple of useful things that I believe SWI prolog CLI is lacking. Anyway, when we invoke the prolog process, we just wait for the standard output data. And if that went well, okay, we expect that to be a JSON. We load it and send it back to the invoking, front end server or CLI script.